Every time you flip a switch, electricity has already traveled hundreds of kilometers, thanks to one unsung hero of the power grid, the transformer. Power plants generate electricity at relatively low voltages, but transmitting that power over long distances at low voltage wastes enormous energy as heat. The solution? Step the voltage way up for transmission, then step it back down before it reaches your building. A transformer has two coils of wire, the primary and the secondary, wrapped around a shared iron core. When alternating current flows through the primary coil, it creates a constantly changing magnetic field in the core. That changing field induces a voltage in the secondary coil. No direct electrical connection needed. This is Faraday's law of electromagnetic induction, discovered in 1831, and it's still doing the heavy lifting in every grid transformer today. The magic lies in the turns ratio, the number of windings on each coil. If the secondary coil has 10 times more turns than the primary, the output voltage is 10 times higher. That's a step-up transformer. Flip the ratio, fewer turns on the secondary, and you get a step-down transformer. The relationship is elegantly simple. V1 over V2 equals N1 over N2. Voltage scales with turns. And because power must be conserved, when voltage goes up, current comes down proportionally. In a typical grid, a power station generates at around 11 kilovolts. A step-up transformer boosts that to 400 kilovolts for long-distance transmission, dramatically cutting resistive losses. At the other end, a series of step-down transformers progressively reduce the voltage, from the grid to the substation to your street, and finally to the 230 volts at your wall socket. Without transformers, long-distance power transmission would be hopelessly inefficient. Modern power systems achieve transmission efficiencies above 95%, largely because of this simple, elegant device with no moving parts. Two coils, one iron core. And Faraday's insight from nearly 200 years ago, still powering the world.